Give me a second.
Sure.
Okay. Hi, everybody. Good morning. Thanks for joining the OCP Tech Week. Today, we will have a slew of events for open system firmware track project. There will be a lot of interesting things going on. I hope you enjoy the day. We have a lot of, I look forward to discuss with all the industry colleagues, and we can communicate and learn from each other. So let's get started. So today, in the open discussion, we have a panel of topical experts. We'll give updates on the respected topic area. And we want to listen from you. Any question, just feel free to ask. And this is our agenda, that for the first 10 minutes, we will go through the OCP chair, Ryan from Google and Reddy from Intel will give overview of the day and the OSF project update. And 8:10 to 8:20, hey, we will have some icebreakers. We have some quizzes. So let's see who will win. Even though I don't have a prize, so we will have virtual prizes. 8:20 to 8:50, we have the topic updates, and 8:50 to 9 o'clock is open discussion. With that said, feel free to ask a question anytime. You cannot talk, but you can ask your questions through the chat window. Thank you. So with that said, Ryan, please go ahead.
All right, thank you so much, Jonathan. So today we'll start with this presentation on the OSF project status, and then we'll follow with a session on how to deliver open system firmware, followed by some demos from Ron, Ampere, 9 Elements, etc., followed by a variety of talks I'll outline on the next slide, and finally the vendor panel. And I really recommend that you stick around for the vendor panel at the end of the day. All right. And so for the talks, there's a number of talks. They're really great talks. We recommend these all in the afternoon in Pacific time. So we have a variety of events going on today, from talks, open discussions, panels, quizzes, questionnaires, etc. All right. And I guess I'll hand it off to Reddy to talk about the key OSF documents.
All right. Good morning and good evening, everyone. So I'm hoping that you have lots of caffeine. Like Ryan said, we have a packed agenda today. So I think that we hear lots of questions about where is the OSF wiki and what are the documents. We essentially wanted to consolidate this and share it with you guys. So the OSF wiki is in the standard Open Compute website, Open System Firmware project. There is a charter, there is a schedule, and there is a checklist. Checklist is the one that you really want to take a look at, because there is a lot of activity going on the checklist side of the discussion in OSF meetings. The mailing list is actually in that link. We have bi-weekly calls, and we have an active discussion going on to figure out if we really want to have alternate OSF weekly calls in different time zones. Please do click on the questionnaire, give us feedback on what time zone and what time and what days you prefer. We want to look at that and figure out the best way to accommodate the interest from the other geos as well. Next slide, Jonathan. OSF checklist. This is, like I said, Ron and Ryan have been doing a lot of work in this space with lots of contributors from OSF attendees. We will cover more details in the follow-on talk, but essentially it boils down to how do you construct an image, how do you install it, and how do you redistribute it, and what do we consider as the OSF, the build, and what are the nuances around how do you grab and construct the different flavors of the images and the source code from the GitHub repos and construct it and then install it and redistribute it in a highly reproducible way. So OSF checklist is something that you really want to take a look at it and start contributing. Next one.
Really, there's a question from the audience. Is that when does OCP plan to approve this OCP checklist and its timeline?
So Ron probably has a better insight into this one. Do you want to take that question, Ron? Approval timeline.
Ron, you're on mute.
We can't hear you, Ron.
I'm unmuted in Zoom. Is that correct? What I'm supposed
Now
to
we
do?
can hear you. Go
We
ahead.
can hear you now.
Okay, so Zoom is the right place to unmute, right?
Yes.
Okay. And the question was on the timeline.
Yes.
I'm sorry, it's still early in the morning. What was this? So the time, can you remind me of the question again? Because
So Ron, question is OSF checklist approval timeline.
yeah. In terms of the V1.1 standard we released, or in terms of documents that may come later, because the V1.1 standard is the checklist as far as I can tell. I'm still not quite. I'm still trying to understand what the question is about. Sorry.
Yeah, when is the incubation committee approving it? When do actually vendors need to following that checklist?
Oh, the original target date is March 2021. If you want to be OCP badged or OCP accepted, you've got to be able to follow that checklist. And I know COVID happened, so there's some discussion about that, but I think we want to try and stick to that March 2021 date. It's kind of been a public date now for probably a year and a half. And we will be hearing from one vendor today, I think, that intends to ship systems that match that checklist.
Thank you, Ron.
Yeah.
Okay.
Sorry, I'm still trying to get back in FN Tech. It kind of kicked me out, so I didn't see the question.
Back to you, Jonathan.
Okay. So it's party time. Sorry, there's no beer, but we can have virtual beers. So first question, what's the OCP market size over 2020? A1 is 1 billion. A2 is 2 billions. The third option is 6 billions. The fourth option is 10 billions. Okay, that's the market size for 2020. So with that said, could you please type in your guess or answers in the FN Tech chat window? Okay. I saw that DJ asked a good question. How do we verify that vendors have complied with the OSF checklist? Do we have mechanism to test and validate? Someone is helping to answer. Thanks. Okay, so for the OCP market size, the answer is 6 billion of 2020. I don't. OCP, yeah. So and it's, I don't know how it grows from year to year, but it grows very fast. Maybe someone can help me whether it's a exponential growth or linear growth. Okay, let's go on for the second question. Okay, this is a fun question. This is meant for fun. So Google so far have made how many contributions to OCP? So the first option is 2, second option is 10, third is 20, fourth is 40. See who can guess this right.
Oh yeah, Jonathan, do you want to show the third question as well? It seems like everyone's on a 30-second delay.
Sure. Let me do that. The third question is how much energy consumption of a server's life cycle is used at manufacturing phase? 10%, 20%, 70%, or 75%? So OSF is an important part of OCP's strategy. And OCP will have bigger and bigger market shares, and the diversity is also growing. And OSF is an important part of growing that diversity and volume. So we hope to, in the future, we hope to see more designs based on the original submission. And that OSF is a key component to enable that. And we also want to see more bigger market shares of non-tier 1 CSP market. And that OSF will also be an important part of it. So for Q2, what should be our answer? So the textbook answer is the first one, 2. So Google contributed the 48-volt rack and hard disk technology to OCP. However, I don't think that answer is correct because Google makes a lot of contributions besides the physical contribution that is currently on book. We know that Google contributed a OCP board member, and Google contributed our beloved OSF lead, Ron and Ryan, Chris, Stefano, Gausha, right? You name it. And Coreboot code base, all those things. So thank you, Google. So let's move on to Q3. The energy consumption. This is an interesting question that you will see that during a server's life cycle, some of the energy are used during the manufacturing of the server, and a lot of energies are used during the operation. We see that in the data center, right? How much cooling we need to have. We always put the data center into high mountains or in Nordic, right? Because it uses a lot of energy. So how much energy is used in the manufacturing phase? Actually, this problem was asked at the last OCP summit in Amsterdam. So the answer is 75%. So a lot of energy are used in the manufacturing phase. So without a working firmware, the server may have to be sold as parts, has to be demanded and sales as parts. But with open system firmware, the server's physical lifetime will be expanded. Okay, with that said, the last question. With working firmware, how much more can a decommissioned server be sold? 20%, 100%, 400%, or 10,000, 1,000%? So that just means if you sell a decommissioned server, you can either sell the parts, you take it apart and sell the parts, or you sell the server as is. Of course, as a customer, I get a server as is. I need a working firmware. So the question is, how much more can a decommissioned server be sold? Yeah, so for this question, actually, I don't have an answer. I hope there's someone from IT venue or in the circular economy business to help me to find the answer. Actually, I don't have the answer. Thank you. I hope you can pin me later on to give me the answer. Okay, with that, let's give a topic update. We will have Jay from CISPRO and Christian from 9 Elements. Jay, please, you're on the stage.
All right, this is Jay from CISPRO Consulting, and I'm just going to give some statistics of what's been happening at Coreboot for the Intel Xeon SP support. And so the support for the Skylake and Cooper Lake platforms has been added to Coreboot over the last year, and it's got quite a bit of support from a lot of different people. There's been, this is as of the end of last week, there was 177 commits from 25 different people, and that's actually got a few more that I know that went in the last couple days. And looking at the actual OCP platforms to Tioga Pass and Delta Lake, to support those main boards, there's been 120 commits from 33 different contributors. So there's a lot of people working on this stuff. Is kind of the point I'm trying to make. And there's been contributions from Intel, Facebook, Google, WeWin, Quanta, 9 Elements, CISPRO. Lots of other individuals have contributed to it and or reviewed the commits going in. So there's a lot of activity going on here. It's certainly getting a lot of support. There's been other core enhancements to Coreboot to support server systems, including MTRR changes, MPNIT changes, and SMM changes, all to support larger numbers of cores and multiple sockets and those kinds of things that are necessary to support the server platforms. So just some recent activity that's been going on with the Xeon SP support is an effort to really remove a lot of the code duplication between the implementation for the Skylake SP and the Cooper Lake SP and create just a common Xeon SP solution. And so there's been a lot of use of common Xeon SP code together with using a lot of the existing Intel common block code to really minimize the number or the amount of CPU specific initialization, that's for these platforms, that's custom for these platforms, and then also trying to use as much as possible of the common ACPI table generation code rather than having stuff specific to these platforms. Also, a lot of effort went into enhance the Skylake SP solution with a lot of improvements and features that were put in for Cooper Lake, and to try and bring the Skylake solution as close to the Cooper Lake solutions possible. And just in this whole deduplication effort that's been going on, there's been at least 50 commits and around 2,500 lines of duplicated code pulled out to really give us some more, get rid of all the code duplication and try and really have a better solution here.
Yeah, Jay, there's a question that is, Coreboot has been entrenched and used in production for many years, has been in there for 20 years. So how does the Coreboot's matureness in the smaller size of systems helps the server side development?
Well, I think that, Coreboot's been around for a long time, and it's been particularly, the support from Intel in the Coreboot space has been going on for several years now. And there's so much community involvement from both companies and other individuals around the world, all contributing and helping debug things and to really make Coreboot much more mature. And because it's all open, everybody can see it and can find the issues and bugs in it and really clean everything up. And it's gone through so much growth and improvement over the years.
Thank you, Jay. Christian, your turn.
Yeah, thanks, Jonathan. Thanks, Jay. There are some maybe security features that we can mention here that have been improved over the last couple of months. We introduced a new SMM loader. So the previous loader only supported 32 threads or less, actually, which is not a good fit if you have scalable server platforms. So we enhanced this so that we do support more than 32 threads now, which is a good thing. IntelTXT support has been added for quite some time now. So the legacy IntelTXT support. Also, BootGuard is the work in progress, but the code is actually already upstream, so you can use Coreboot with BootGuard if you want to. Intel CBNT, so the converged BootGuard and trusted execution technology. So it's basically TXT and BootGuard merged together. Is upcoming right now. So that is something that is under heavy development. We just yesterday booted our first system with Coreboot and CBNT activated. So that's ongoing there. What also has been added to Coreboot as a submodule is the Converged Security Suite, which is basically a validation suite for Intel platforms. So it does validate Intel security features. Plus, you can also provision your platform, which is a missing piece that was missing for quite a long time now. You can provision TXT nowadays, and also CBNT support is on the roadmap and upcoming. Maybe a little bit more to technologies that are planned throughout maybe the next year, I suppose. The standalone SMM support is coming. So that is actually a good thing that we pull out the SMM out of the RAM stage and have like a standalone SMM support there. DDR5 and NVDIMM support is coming up, which is also very important for server platforms there, as well as PCI Express 5, which will also be heavily used on server platforms. And also the Compute Express link is something that will be added, or is at least on the roadmap throughout the next year.
Thank you, Christian. It's nice to hear so much progress. I look forward to it. Next, we have Reddy, please.
All right. Okay, so just one slide summarizing pretty much what Jay and Christian actually mentioned. So the left-hand side picture essentially gives you all the layers involved in actually bringing up an Intel reference platform that is UEFI firmware based. The critical component in this one is Intel firmware support package, which is actually in the red. And we use that as an extension mechanism to support the bootloader of choice that you may have The one that in this picture is actually giving you an example with Coreboot. This can be any bootloader that uses either the dispatch mode or API mode. If you're going to use the dispatch mode, obviously you're going to anchor towards UEFI firmware-based, the platform code and the bootloader. If it is an API-based integration model, you are looking at Coreboot, Coreboot, Slim bootloader, or any other new bootloader that you may have that essentially uses the API mode. So we do support both integration models. With the Coreboot, essentially Intel FSP API being used. And then we have done quite a bit of work in the community, like you heard before from the prior speakers. So there are two distinct focus areas when we started the Coreboot work in the community. One is bring up the two-socket Skylake SP platform on the Open Compute Tiaga Pass board. This is purely meant as the POC, and experimental, the focus, primarily to bring in all the Coreboot Xeon SP related functionality quickly to the market, and use that as a starting point for us to actually look at supporting production implementations. Then we switched over to the next generation, processor, which is called Cooper Lake. Most of the focus for the Cooper Lake has been on the one-socket Delta Lake OCP platform. And you heard quite a bit about the security aspects as well as some of the refactoring aspects between the Skylake SP code and Cooper Lake SP code, essentially, coming from those two platforms and the related effort. Two distinct FSPs. Skylake SP FSP is different from Cooper Lake FSP. The common integration points based on the FSP spec are common between those two, but the hops and UPDs, there are some subtle changes. Lot of work in the Coreboot community. The common foundation libraries, we had to change them. So the MP init, for example, essentially times out if you have large number of cores and hyperthreads, especially on the two-socket platform. So we had to do some refactoring work on the MP init code. MTRR settings, specifically supporting the large memory footprint, some serial IO related optimization, specifically with the A-speed, the chip, SMM side of the optimization to support more cores. And on the Xeon SP side, the memory map for the server platforms is quite different from compute core the client platforms. There is bit of optimization on the memory mapping part. Multi-root IO, essentially it's in multi-root PCIe. The configuration requires different way of enumerating the PCIe devices, as well as allocating the bar both for 64-bit as well as 32-bit prefetchable and non-prefetchable. MSR settings are quite different for the server platforms. There has been quite a bit of work in the ACPI table stitching. As you can see, the list and that is growing, and we'll end up doing more and more work to support the persistent memory and other artifacts coming up next year. Lot of FSP interface optimizations, because this is the first time we have been doing the server side integration with Coreboot. Both UPDs and hops, we had to essentially look at what is the best way to support the server platforms. Things like PCIe bifurcation is something that is very, very important for the server platforms. So there has been a lot of work in that space. And then obviously, as Jay talked about, common code refactoring between the Skylake work that we have done very early on, and then the Cooper Lake work that is currently going on. Going into 2021, first and foremost, Intel priority is to enable the ecosystem to ensure that we have OSF compliant platforms that are running the Xeon SP processors. We will support whatever ecosystem needs to ensure that they are essentially getting the badging and logo requirements. The second one is upcoming platforms. We would like to essentially extend the Coreboot support for Ice Lake and follow-on platforms next year, with specific focus on the Compute Express Link, there is a industry-wide effort that is going on, and our goal is to bring in that functionality into Coreboot. There is PCIe Gen 5, DDR5, aspects that we want to ensure that Coreboot works, for the next generation PCIe and DDR5, DDR interfaces. Hard plug support, we need to actually focus on the hard plug support, especially for device connectivity, and support different Delta Lake configurations. Persistent memory has been the other focus area that we really want to bring Coreboot functionality on par with the UEFI firmware. RAS is something that it's going to evolve over the couple of generations. We'll start off with anything that is OS first and make sure we support the RAS functionality that is exposed, managed through OS, all the plumbing needed in Coreboot. We want to go address that. Security side, PFR integration, which is the platform root of trust, converged boot guard and TXT support. And last but not least, the continuous integration testing and test automation is something that I'm very passionate about, primarily because it brings in the efficiency in bringing up the platforms very quickly. So we are going to focus quite a bit on how do we, build automated test frameworks around Coreboot to validate, build, sanitize the platforms very quickly. Things like, we could be looking at a payload as an example. It could be a test payload. We run the test payload, it tests everything, and then essentially it says everything is passed. So this is very critical for us to bring in the new platforms for Xeon SP very quickly to the market.
Thank you, Reddy. So there's a question from audience: is when will Intel be making the Cooper Lake FSP binary for the OSF compliance or board OSF development available to the community?
Good question. Currently, the Cooper Lake testing is going on for the Delta Lake board. We want to essentially close on anything that is high priority related open issues. And then once we have the stability with the FSP, we want to make the FSP binaries with the header files available for publicly downloadable images, that either for the community development or is it for the OSF badging requirements, either one of them.
Thank you, Intel team. So next is about Linux boot. Chris Koch from Google, he's not able to join this morning, so Ryan will help him out. Thank you, Ryan.
All right, thank you so much, Jonathan. So this is a quick overview with the current status of Linux boot. So a big topic of discussion is the EFI bootloader. We're trying to pick up that work again in order to boot operating systems such as Windows and ESXi, which depend on an EFI bootloader. Currently, the approach that Linux boot takes is to use a kexec, which predominantly only supports Linux at this time, but we think we can tweak it in order to boot general purpose EFI operating systems. I guess the call to action is, if you're interested in this work, please do join the uroot Slack channel. That's where this is discussed. Maybe someone could comment that in the FNTech tool. But if you want to learn more, do follow Slack. And then in terms of uroot, there's been a number of improvements over the last year. So the grub parser is certainly improved. It supports more operating systems, and I see people are now booting Red Hat, OpenSUSE, Ubuntu, etc. We now support the bootloader spec. There's ESXi support without multi-boot now. And yes, support for CentOS as well and Red Hat Enterprise. Next slide. I think there's a bit more to talk about uroot. Yes, that's right. From Ron Minnick.
Hello. So there's been a lot happening in uroot this year. I think a lot of it really did focus around booting, and really fine work from Ryan on improving our grub parser. There's now 148 commands, and if you kind of take that over the 120 months or so the project's existed, it's essentially seems to be about a new command every month coming in. I forgot to mention it here, but I'm working on a command to allow us to boot fit images. but we can net boot over IP4 and 6 and HTTP and all kinds of things, including actually iSCSI now. So this is being deployed by different companies on Intel, AMD, and ARM systems now. And if you actually look, and I'll talk a little bit about the mainboards repo later, but Ampere actually has placed build for Linux boot and uroot in the mainboards repo. So one of the things I got sensitive to in the last 6 months was a concern that we were becoming a little too Linux centric or Unix centric. So as an experiment, I actually helped run another Plan 9 project. So I decided to start targeting Plan 9 because that's one of the great things about Go is it does have a very, very wide range of kernels. And we found 38 commands, and I slowed down a little recently because ironically, we've been working on OCP Tech Week, but we do now have 38 commands that run under Plan 9, and that's been a nice opportunity to sort of clean up the code base and make sure that not too many Linux assumptions were bleeding into the commands. The other thing that's kind of happened is that it did resolve a question, at least in my mind. We keep getting asked about whether we should use Go or Rust, and I think that from my point of view, because I use both, the fact that Go has a runtime that's basically kernel agnostic if you're careful and not even that careful really made it pretty easy to make this work. So in general, I can take a command, compile it in seconds. It may fail for Plan 9. Generally, the remediation for any Linux kernel dependencies having crept in is a couple of minutes. So I have found myself really liking the fact that Go has a fairly portable API across kernels, which is not really something I found to be true in Rust. I think there's an awful lot of Linux particular dependency in some of the things I've done with Rust runtime. So I love Rust, but for uroot, I think I'm planning to stick. I personally I'm happy we went with Go. We do have a nice looking boot menu for those who want it, and further, we've got a neat project called Web Boot done by interns, which allows you to boot many different distros dynamically every time you turn on your laptop. And that has a very, very nice API based on the Go Term UI. So people have asked about what we want to do about something that looks like a decent text-based UI for Linux boot. And I think we're rapidly coming to closure on how that should look. And the Term UI is fairly light in terms of space, but fairly capable in terms of what it gives you. So any questions on uroot?
Thank you, Ralph. So
Yeah.
that's exciting. I'm eager to learn things about the Plan 9 and the nice looking menu. So hopefully you can show me today maybe something. Thank you. So next is Isaac about Mean Platform. Isaac, thank you.
Good morning. Next slide, please. So just a brief update here today. I want to talk about the EDK2 minimum platform and where we are closing out 2020. So it's been a big year. It's been pretty busy. It's been quite a year. So we're a little off from where we wanted to be. But in general, I would say our production pilot projects are progressing well. And are on track towards completion successfully. And some of the key concepts of the minimum platform are really starting to pay off, and we're comfortable that they're working. So we're able to get the consistent boot flow between client and OSF and full enterprise class server systems and things like that. So the common minimum platform architecture spec is working as intended. We're able to leverage the EDK2 and UEFI components. Well, that wasn't really in doubt, but some of the more silicon specific components we did have questions about, and we've been able to prove the ability to reuse these reference platform components from our full featured Intel platform and to be able to export them into the minimum platform successfully. And so this allows people to create the open system firmware that they want while still extending it with the proprietary features that are rich in the ecosystem. So you can have OSF with BIOS vendors, with proprietary solutions, as well as meeting the checklist and getting into that circular economy. So we're happy about that progress and that proving itself. And then we're also happy that we're able to successfully produce the reduced feature set systems, because this is what a lot of OCP systems will need is not everything in the kitchen sink, but a more reduced feature set. So in general, we've been happy with the progress in 2020. We're a little behind. We're excited for 2021, where we see a lot of activity coming to fruition in real systems. So, and then the final thing that we'll talk about later in the day in the longer section is our efforts to open source the Cedar Island Min platform port and the associated binaries. So that's my brief update, Jonathan. Any questions?
Yeah, thank you, Isaac. There's a question, is that with which OCP platform will Min platform be submitted together with the server submission? Is that something Intel knows?
That's not something I know or can speak of, but I think 2021 should be interesting, and we'll see lots of activities from a lot of different ecosystem players. So I'm thinking we'll see good examples from multiple places.
Thank you, Isaac. That will be exciting. So next is test automation. Philip, you're on.
Yep. Hi, this is Philip from 9 Elements. So the testing effort is let's say a new sub-project from the Open System Firmware Working Group. It started a few weeks ago, basically, or months ago probably, where we found out that the certification process for the OSF accepted and ready certification is not that, let's say, complete and good to handle. And it's also quite loose. So we don't test specific things which should be tested if we want to run open system firmware on specific hardware by vendors which are submitting their hardware for review to the OCP to get a certification. So there also, aside from that, there are no real hardware tests. So if the hardware really boots up with open system firmware yet. And so we decided to improve the overall quality of the process, right? So this should be an important thing. And so far we decided on a short plan. So it's not everything is set in stone. If you want to discuss more with us in the Open System Firmware Working Group, please do so. So far, we decided to go with independent testing providers, which run the test and the test plan from specified and delivered by the OCP. And so hardware vendors can contract them and submit their hardware or remotely attach it to their system. And the service providers will then run the test and the test plan from the OCP itself. Yeah, that's it. Jonathan, can you switch to the next slide? Thank you. So the roadmap for that, for overall to make that happen, is that in Q4 2020, we will try to find and discuss with some testing service providers so that we have a specific amount of testing service providers there, right? That we don't have one and have multiple where we can choose from, and also the OCP members can choose from. Aside from that, we as 9 Elements will provide an initial test specification proposal for further discussion with the OCP and also the service providers if we have decided on them. And yeah, after that, the proposal is delivered to the incubation committee in Q1 2021. And after that, we hope that we get into the OSF checklist by 2022. That's it so far. Yeah. Yeah, thanks for listening. If there's any question.
So I've got one that's on the chat window, so I'll represent that. Who are the certification labs that do the certification, or is it self-testing and self-certification?
No, it's so there's the testing providers are basically running the test plan and check the test specification. The hardware vendors just sent in hardware. So, and currently there's only us 9 elements we committed for it, but there should be different others testing service providers, right? And they should be independent. And so it's not decided yet who this will be. As far as I know, SysPro is also looking in that. Correct me if that's wrong, Jay. But aside from that, there are nothing more testing service providers yet. So we will figure that out in the next few weeks, hopefully.
Yeah, I mean, we are basically trying to figure out the best way to structure the independent providers who can actually do the testing, and how do we tie in that with the OSF logo and badging requirements, as opposed to the provider doing the testing and saying, okay, I passed everything, right? So that process discussion is still going on, but I anticipate this one goes through the incubation committee for approval, and that is likely going to be the focus for the first half of next year.
Cool, great. So any other questions? Please put input to the chat window. I'm also going through to see if there's anything interesting. We have 11 minutes left to ask the questions. Take a good chance of this. We have so many experts here. Let's learn from each other. Yeah, DJ has an interesting comment that with 4 years life cycle of a server, I would say 10% during manufacturing phase. So yeah, the answer is a little surprising to me as well. So a lot of powers going on to make the server. So yeah, we want to make the server's life longer because it spends so much energy to build them.
So while we're gathering questions, I did have one about the Linux boot anything. There was a comment about OSs will remove legacy boot. Could we expand on that a little bit? What timeframes we see and what we think that means for Linux boot?
I feel like Chris Coe would be able to speak to this better. But we have some operating systems, I think possibly Windows, perhaps ESXi, who are going in the direction of only supporting an EFI boot mode. So other modes such as legacy are incompatible. But I'm not too familiar with that timeline, unfortunately.
Yeah, as far as I know, so from the Linux boot community, we are working on the UEFI support as well, right? So at least that we can boot UEFI applications. I think this is a midterm goal. As far as I know, they're also already working people on integrating that. So it will come on some point. For sure, we're supporting the legacy systems as well, right? So that depends. There are multiple companies using legacy systems still, and they just don't want to get into the UEFI direction. It depends on the customer, I guess. But we definitely support both ways. And aside from that, you can for sure just go with Linux boot without having any, let's say, legacy or UEFI booting mechanisms. You can also directly chain load something with other specific methods from a Linux kernel, which makes it also even more innovative or attractive, in my opinion. Yeah.
Yeah, I think from a UEFI and EDK2 perspective, we've seen a lot of interest in expanding the UEFI adoption into embedded and other spaces where OS loading is a little more chaotic, and UEFI provides a good industry standard way. So we're obviously very supportive of UEFI as the standard way of booting things. And then also we have had longstanding concerns about the challenges of securing legacy boots. So we like to see more progress that way as well.
Yeah, makes sense, Isaac. There's an effort to try to streamline UEFI interface. If that works, I would imagine it would make it easier to get into embedded space for UEFI. Any other questions? So I'm showing today's overall agenda. So we have the next hour, 9 to 11, we will have on Google and have the host the event of how to.
John, this
Yeah.
is Rajiv. I just, maybe you guys have already addressed it. There's a new question from James in the FN chat window. What's the timeline for the mandating OSF on OCP system? Did you guys already answer that?
I answered it very poorly. So let me try again.
I guess yeah.
Yeah, there was a timeline. So let me walk through that again. And Brian will jump on me if I get this wrong. So September 2019 was when we got an agreement on a timeline, and I'll tell you the end of the story first. March 2021 is the date by which vendors are expected to provide OSF compliant systems. And so the September date was September 2019. We kind of got approval from the incubation committee. March 2020, I believe, is when we pretty much broadcast that timeline, even though we were hinting at it for a while. This was going to be the conference in Prague where various vendors demonstrated their OSF compliant systems. And I believe HPE is going to be doing that today. And then March 2021 was when we felt that it would be possible to do it. The timeline actually was developed in March 2019. We had a lot of people in a room from Intel and Amazon and Google and Facebook and all these other companies. And we, at the time, it seemed like it was not too an aggressive timeline. So we've kind of really tried to stick with that. It's always going to be a bit of a difficult event to make this kind of change, but we don't want to drag it out forever either. So we put a stake in the sand at March 2021, and we're because there are vendors already planning to adhere to that, we're actually feeling that we need to stick with that current date. Hope that helps. Please talk to me offline if you need to know more, or Ryan or Reddy.
Thank you. The OCP OSF needs. Thanks for the volunteer effort. It takes a lot of time, but that's for the industry good. Thank you so much. Okay, with that, we conclude this open discussion.